Hey everyone, welcome to our presentation on the utilization of CD34 positive cells for early detection of AML relapse post-HSCT. Today we'll discuss the complexities of cancer treatment, the challenges of relapse, and the importance of ongoing research and support for those affected. Let's begin by understanding what AML is. Allogeneic hematopoietic stem cell transplantation, or allo-HSCT, is the only curative option for many acute myeloid leukemia patients, specifically those in the risk stratification level. However, relapse remains the leading cause of mortality post-transplantation, with over 50% of high-risk patients relapsing within the first 2 years and only 10% achieving long-term survival. Therefore, it is imperative that we identify prognostic factors associated with relapse, and furthermore, these preemptive treatments of relapse are more effective when guided by early detection. Therefore, we must identify a predictor that is highly sensitive, specific, and allows for enough time for intervention. The method used today to detect for relapse involved monitoring donor chimerism percentage, as is an independent risk factor for relapse and survival. Currently, at our center, we use CD3, which is a lymphoid line, and CD13 and 33, which are myeloid lines. However, there's upcoming literature that proves that CD34 is better, and this primed us to study chimerism assessment in purified AML-specific target cells using CD34 and its ability to act as a predictor for relapse. This brings us to our primary goal, which is to evaluate the utility of CD34 positive cells in chimerism analysis through PCR-STR at the 3-month post-transplantation for AML patients who have undergone myeloablative conditioning. Additionally, we will compare the predictive abilities of peripheral blood and bone marrow samples taken at the 3-month mark. We have two main objectives to reach this. The first is to isolate and sort for CD34 positive cells at the 3-month from peripheral blood and bone marrow samples in both relapse and non-relapse patients, and the second is to calculate and identify the sensitivity, specificity, NPV, PPV, as well as Udin's index. This brings us to our methods section. First, we would prep the samples where we would prepare MNC cryopreserved vials for the assay. Next, we would use multicolor flow cytometry using FACS or fluorescence activated cell sorting. Then we would perform DNA extraction on the isolated CD34 cells. And lastly, we would do the STR-PCR process and conduct chimerism analysis. And this brings us to our results section. And this brings us to our cohort size. As you can see here, in our peripheral blood, we have 35 relapse patients, along with 98 non-relapse patients, bringing our total to 133. With bone marrow, we have 8 relapse patients and 17 non-relapse patients, bringing our total to 25. Here we see an ROC curve. An ROC is a graph to show how good something is at modeling something else. In our case, it shows how good CD34 positive is as a model of predicting relapse. The reference line in the middle, in red, you can see has an AUC of 0.5, which means the model has no discriminatory power to distinguish between positive and negative classes. We can see here that our AUC, generated by CD34 in peripheral blood, only provides an AUC value of 0.5966, which honestly is not great. And therefore, we developed a solution. We decided to exclude any patients that had relapsed after day 180 or the 6-month time point. This time point was used as it is the next time point where majority of patients give blood. Therefore, any patients that relapsed after day 180, such as those who relapsed at day 700, were removed from our calculation. With this, we saw a decrease of 22 peripheral blood patients who had relapsed and 4 bone marrow patients who had relapsed. And now we see this new ROC curve. The blue line is the same line shown on the previous ROC curve with an AUC value of 0.5966, and this represents all peripheral blood samples. The green line shows the peripheral blood samples with the exclusion, generating an AUC value of 0.8146, giving evidence that CD34 positive is a good predictor of relapse. Furthermore, the difference in the ability of CD34 positive to act as a model for relapse was statistically significantly different, with a p-value of 0.0021, and this further gives evidence that with the exclusion, CD34 positive is a good predictor of relapse. Here, we can see the same green line that was previously shown, and now compared to the AUC value of the bone marrow samples with the exclusion. The bone marrow samples with the exclusion generated an AUC value of 0.7059. However, these results are not statistically significantly different. And this is likely because of a larger standard of error because of the smaller sample size for the bone marrow, as there is only 4 relapse patients that are visible. And this begs the question on why we would even do bone marrow, as it is more invasive and oftentimes lowers the quality of life for patients. The threshold values represent donor chimerism percentage, with 95% being what we currently use clinically. As we increase the threshold, the sensitivity increases while the specificity decreases. This evidence suggests that we could use 93% as the donor chimerism cutoff, as it matches the highest sensitivity as well as maintaining a high specificity, and also provides the best balance, indicated by the highest Udin's index value. This brings us to our 3 main findings. First, peripheral blood is as predictive as bone marrow samples. Second, this data suggests that we could use a threshold value between 90 and 95% donor chimerism. And lastly, patients should receive checkups every 3 months for greatest chance at RFS. These are my references. I would like to acknowledge the Arnie Charnabel Cancer Institute, as well as all members of the Construct Laboratory for creating a safe and positive environment for conducting research.